So, welcome you all for the second session on steel structures. In the last session, we discussed some of the basic concepts of load and load combinations, partial safety factors, limit state design concepts, and also the types of joints. So, we discussed in detail the types of bolted joints and also the failure of bolted joints. So, this session will discuss on some of the problems on the bolted connection and also the welded connections. So if you take one of the example here, so here they given four types of pattern of bolts. Here they are asking for us to identify most effective butt joint. So butt joint means we know already one. If you keep one adjacent to other, that we call it butt joint. This plate number one, plate number two. Okay, this is what your cover plates. So these two will be your main plates. Okay, this is a butt joint. They given some pattern of bolts, which one is the effective one. So if you give diamond a staggered pattern, they are the the most effective pattern when compared to the rectangular pattern or other pattern. Therefore, so here option A is the correct answer. So if you go for next question, a rivet value. Rivet is nothing but a type of a bolts. Nowadays, people go for rivets only in case of bridges. So for other type of structures, we're going to use bolts. Here, the rivet value or the bolt value. Bolt value, what we discussed in the last session. Bolt value is the least value of the shear strength of the bolt and the bearing strength of the bolt. In the similar way, in case of rivet, the least value here is the bearing strength of the rivet and also the shear strength of the rivet. Option option A is the correct answer. If you go for next question, in a steel plate with a bolted connection, the rupture of net section, the mode of failure. If this is a bolt, this is the plate. If this is what your bolts, if you use one row of bolt like this, okay, three bolts are used. If you apply force on this, what will happen? Here there will be a occurrence of rupture will happen here. So here we should take what net section. Okay. Therefore, in case of net section, so because of these forces, here you're going to get the tension mode. Okay. The here option A is the correct answer. So piring force is the forces. We all know that this is occurs due to the option number B, tensile forces due to the flexibility of connected parts. The next one is the combined capacity of the rivets or bolts subjected to. Here, the for this question, the answer here is C. The ratio of tau VF calculated by tau F, that is shear stress in the material, plus the tensile stress calculated by tensile strength of the member does not exceed 1.4 as per IS 800. So if you go for the important problems on bolted connections, why important? These same type of connections they are asking for 2 marks from from the previous year question papers. If you observe, they are asking frequently these type of questions. So we will discuss in detail this first problem. So we'll read the problem now. A bracket connection is made of 4 bolts 10 mm diameter and supports a load of 10 kilonewton at an eccentricity of 100. Here is this is what your bracket load 10 kilonewton, which is having eccentricity from the center of the column, that is 100 mm. The maximum force, the question here is the maximum force to be registered by the bolt is. So here they given the pattern like this. There are 4 number of bolts, 1, 2, 3, 4. Okay, from this center, the distance, if you take this as a center line, okay, the x distance will be for these 2 bolts would be 40. For other 2 bolts, that is 1, 2. If you mark the bolt number like this, 1, 2, 3, 4. Okay, so for bolt number 2 and 3, the x value from the center will be 40 millimeter, whereas y value for 2 is 30. Y value for if you take this as a center line, y value for bolt number 3 will be again 30. Okay, so this is what your pattern of the bolt it is given. If you take this as center one, if you take back, if you go backside again for bolt number 1 and bolt number 4, the value will be 40 only. Okay, x distance. Okay, so this one here we have the 4 bolts. What they are asking here is they want the maximum force to be registered by the bolt. So actually for this pattern, so that is bracket plate and the eccentric load pattern, because of this load, the extreme bolts in the pattern will absorb more force, nothing but the extreme bolts will resist the more force. So what are those extreme bolts here? So number 2 is the extreme bolts, number 3 is the extreme bolt, okay, number 1, number 4, all 4 are here are the extreme bolts. Okay, sorry. So out of these four bolts, if you take any one, all the bolts are the same distance. If you take three, so the x will be 40, y will be 30. If you take two, x will be 40, y will be 30. If you take one and four, again x will be 40, y will be 30. The distances. Okay. So here all the four bolts are the they are carrying the extreme forces. So now what I will do, I will select one of the bolt here. So in the here, this is what the solution. So here they considered here the first bolt, second bolt as the extreme bolt. Okay, for this they drawn in the radial line from the center of the pattern. Okay, that radial line inclination they have taken as theta, whereas here they have written F1. What is this F1? F1 is the force due to the direct force. Force due to the direct force of the shear because of the 10 kilonewton, because of the application of the force acting downwards. What will be the force acting on this bolt? That they taken as F1. Okay, what is F1? F1 is the force acted upon by the direct force 10 kilonewton. Since there are four bolts, this will be shared by four bolts. Therefore, whatever the force you applied, that is P or the 10 kilonewton, will be shared with four bolts. Therefore, your answer is 2.5 kilonewton. Then if you go for F2, what is F2? F2 is the force which is going to act perpendicular to the radial line. What we drawn earlier for that radial line R1, it will going to act perpendicularly. So this is due to the stress due to moment. For this, we should calculate F2 using this formula P into E into R1 divided by sigma Ri square, where P is the external load 10 kilonewton, E is the eccentricity, okay, 100 millimeter here, R1 is the radial line we should calculate, and also Ri square is the radial distances for all the bolts. Okay, so this is what F2. F2 is what? F2 will going to act perpendicular to the radial line. So this is the F2 is the force induced in the bolts due to the moment. So this one we need to calculate like this: P R1 by sigma R square, where R here in this case, if you take R1, if you take this bolt, if you take this bolt, all the bolts, the R1 value will be same. R1, R2, R3, R4 all same. So if you go for this triangle here, so then what is R1? If you apply Pythagoras theorem, opposite square by adjacent square. So opposite here is 30. So adjacent is 40. If you take this triangle, okay. So then your R value will be 50 mm. So if you substitute here, so the P is 100 kilonewton, E is so P is 10 kilonewton, E is 100 mm. So P is what the R radial distance. So where here sigma R square is the sum of x square plus y square for all the members. If you go for sum of x square plus y square, x is the 40 square plus 30 square, okay, into 4. Then you will going to get 2500 into 4. So here what is 2500? It is a sum of sigma Ri square. What is sigma Ri square? Sigma Ri square is the, so here if you take R square for one bolt, that is x square plus y square. So here x is 40. So 40 square plus 30 square, you will going to get 2500 into, since there are four number of bolts, you need to type here four numbers. Since there are only four numbers of bolts, we should take four. If it is five numbers or other numbers, we should take here number of bolts. So then if you substitute here, you will going to get F2 as 5 kilonewton. So F1 here is 2.5, F2 is 5 kilonewton. This F1 due to the direct force, it will be shared by all the bolts, where F2 is the force induced due to twisting moment. Therefore, if you substitute to the formula, since there are two forces acting at a common point, concurrent force system, if you apply resultant force formula, resultant force equal to what? So F1 square plus F2 square plus 2 F1 F2 cos theta. What is theta? Theta here, the angle between the radial line and the horizontal centroidal line. So then in this figure, theta will be opposite by adjacent. What is your opposite? Tan theta. Opposite here is 30. Okay. Adjacent here is 40. So 30 by 40, you're going to get 37 degree. If you substitute to the resultant force, so then your answer is like this: 7.16 kilonewton. So F1 is 2.5 square, F2 is 5 square, 2 F1 F2, that is 2 into 2.5 into 5 into cos 37, you're going to get 7.6 kilonewton. So your answer here is D is the correct answer. Okay, so many times they ask these type of questions only. I will repeat this problem. So here we should take First, we always have to calculate F1. What is F1? F1 is the force on the bolts due to direct shear. So that will be equal to total force acting in the member on the bracket plate divided by number of bolts. In our case, number of bolts is only 4. Where F2 is the force due to the moment because of the bracket load. P into R1 by sigma RA square we should calculate. If you calculate, R1 and also sigma RA square, then you can calculate F2, then you calculate theta, the angle between the radial line and the horizontal, the centered line, okay? Then you can substitute to the resultant force formula. Resultant force is the maximum force that will be carried by the bolts. If you go to the next problem here, so what is the next problem? The bracket plus connected to the column flange transmit 100 kilonewton load, whereas in the previous problem it was 10 kilonewton. In the following figure, the maximum force for which the bolt should be designed. So here again the extreme bolts here are 1, 2, 3, 4. So inner bolts, this middle bolt will not be under extreme condition, will not receive the maximum load. So only as always we should take the extreme, bolts like this. So this is the extreme one. If you take this as extreme one, or you can take this as extreme one, or you can take this or this. Okay, again the procedure is same. So you should calculate F1, you should calculate F2, and then you should calculate theta and also resultant force. What is F1? F1 is the force induced on the bolt due to direct force. So F1 is always going to act downward direction. Since 100 kilonewtons are acting downward, F1 equal to 100 by number of bolts in the pattern 1, 2, 3, 4, 5. Therefore F1 equal to 20 kilonewton. If you go for F2, what is F2? We already discussed in the last problem. F2 always we should write perpendicular to the radial line. Therefore F2 will be equal to PR by sigma R square, where P is the eccentricity, P is the load acting in the member 100 kilonewton, E is the eccentricity. Okay, 600 millimeters is nothing but 0.6 meters. Okay, and here also they submitted here we put the dimensions in millimeter. That's why they are taken here as in terms of meter. Otherwise, you can substitute in millimeter also. Finally, answer will going to get in kilonewton only, similar to last problem. So here P is 100. So E eccentricity is 600. Then you should calculate R value. How to calculate R? R is the square root of opposite square by adjacent square. If you take like the triangle like this from center here like this, so here the distance here is 75 sy. Okay, so x also 75. So then your answer will be, so 75 root 2 is the R value. Then if you take sigma R square, if you take R value for individual bolt, for since all the bolts are at the same position, so therefore your R value will be 75 into root 2 square into 4 is the number of extreme bolts which are available here. If you take center 1, what is your x distance? 0. If you take center 1, what is your y distance? 0. That's why they have taken only the extreme bolts as 4. Okay. So then if you calculate F2 value, here your F2 value here is 141.42 kilonewton, where theta equal to 45 degree, and therefore your resultant force will be F1 square plus F2 square plus 2 F1 F2 cos 45 degree. So I got in the 45 degree tan theta equal to opposite by adjacent. Opposite is what? 75. Adjacent is also 75. Therefore theta will be 45 degree. This is what your answer, 156.2 kilonewton. Here you should substitute, you should type this answer. This is a non-multiple choice question answer. Here you should type this answer in case of examination. This problem is exactly similar to the previous one. If you go to next problem, again the same pattern they given, but they given the distances in a different way here. Okay, here the column is subjected to the load through the bracket as shown in figure. Okay, here the load here is 10 kilonewton, eccentricity is 15 centimeters, nothing but 150 mm. Okay, here what I want from this center line. Okay, center line, what I want this distance, x distance and also y distance for the extreme bolts. Here we have the 4 extreme bolts, 1, 2, 3, 4. But they are asking here the resultant force in kilonewton up to 1 decimal place. Okay, in this bolt, in number 1 bolt. Here what you want radial line, correct? You want radial line, you want x distance, you want also y distance to calculate theta. Now I will go for F1. What is F1? F1 is the force acting downward on this member. That is, F1 is total force divided by number of bolts, 2.5 kilonewton. Where what is F2? F2 is the force acting in the member perpendicular to the radial line. Along this line, it will going to act like this. This is what your 90 degree. So here they written 90 degree. F2 here at a distance of from the radial line, it has to act at an angle of 90 degree. We already know that from the previous two problems. Where F2 is what? P into E into R1 by sigma Ra square. Here P is 10 kilonewton, E is 15 centimeter. Anyhow, if you substitute E in terms of meter or E in terms of millimeter or E in terms of centimeter, automatically it is going to cancel, because since we used Ra square also in terms of the same unit. Okay, so here P is 10 kilonewton, E is 15 centimeter, and number of bolts here is 4 number of bolts. The value of Ra square will be like this, x square plus y square. Okay, what is x? So r square equal to here x square plus y square, that is 5 square plus 5 square. That's why they written directly as 5 square, since there are 4 bolts. So your okay into r, here r equal to how much? R equal to square root of, yeah, I know the x and y. Here x is 5, y is also 5, therefore here r is also 5, therefore F2 is 7.5 kilonewton. Okay, so now, since we know sigma Ra square R1 and also P into E, Fr equal to resultant of F1 and F2, that is square root of F1 square plus F2 square plus 2 F1 F2 cos theta, you're going to get the answer as 6 kilonewton. Okay, this is what your answer. This is the force acting in the extreme bolt, that is 1. So here they directly asked the bolts and the value of the resultant force at this bolt only, not on the other bolt. If you take on if you calculate on the other bolts, then also you're going to get the same answer. So if you see the next problem, exactly similar to last three problems. So if you observe here, so they may ask again the 2 marks question from this type of questions, but you should know how to calculate R value, F1, F2 here. If you know those things, immediately you can calculate the answers. So now we'll read the question. 4 bolts PQRS. This is PQRS for equal diameter are used for the bracket to carry a bracket load of 130 with an eccentricity of 200. So this what is center, they're directly given this problem. Okay, from this center line, if you take the x distance for PQRS will be 50 mm. If you take consider this is center line, so from this center line the y value will be for a PQ for all the bolts will be 240 by 2 120 millimeter. Okay, so what they want here, the force in the bolt P. So this exactly similar to problem number 1 or last the problem in P. Therefore, you calculate first P F1. F1 is what? P1 by P by number of bolts. Here P is 130. 130 by 4 equal to 32.5. Where F2 equal to PE by sigma R square into RP. RP is the radial distance from the center to the P bolt. Here, since all are placed at the same distance, okay, your RP, RQ, RS, excuse, RP, RQ, RS, and all the bolts having the same R value, since from the center line which are located at the same distance. Okay, so R value will be square root of x square plus y square. We know already this one. 50 square plus 120 square will be 130 millimeter. Whereas in F2 is what? We know the formula, P into E into R divided by the sigma R square. If you calculate sigma R square is nothing but x square plus y square. So x square plus y square is nothing but what? So nothing but you're going to get the 130 square, since they are exactly located at where at the center, where 4 is the number of bolts here. Okay, so here P is 130, E is 200, E is 200, and the R value is 130. If substitute, you're going to get F2 as 50 kilonewton. If you calculate cos theta here, if you go for cos theta directly, they calculated here what opposite by adjacent side, sorry, adjacent side by hypotenuse side. Hypotenuse side already known, that is 130. Therefore your resultant force will be f1 square plus f2 square plus 2 f1 f2 cos theta. Cos theta just now we calculate. Otherwise, if you want to calculate theta, you go with the same previous problem, that is tan theta equal to opposite by adjacent. Your answer is 69.33 kilonewton. Here option B is the correct answer. Okay, this is the fourth problem. They asked on the same type or the pattern. So this also same thing. This is easier when compared to previous problem. Here also we should calculate what we need to calculate here. A column is built total load of 60 kilonewton. It's a recent gate examination problem. 60 kilonewton supported through bracket connection shown in figure. What we need to calculate here? We should calculate the board. Here they given board, this one, not the extreme board, which is not the extreme board, which will not carry more load when compared to this or when compared to this. Okay, anyhow they are asking on this board, we should calculate on this board. So f1 will not vary, only f2 will vary. Okay, so now if you go for f1, what is f1? From last previous problem we studied, the f1 is p by n. What is p? The 60 kilonewton is the external force, okay, by number of bolts. In this pattern they given how many number of bolts? 6 number of bolts. Okay, so 60 by 6 equal to 10 kilonewton. Here 10 kilonewton. Whereas f2, before calculating f2, first we need to know the e value, that is directly given here. From here to here, how much? E value 100. Okay, so what about load? 60 kilonewton. Okay, what about r value? How to calculate r value? From here to here you should write the radial line. So what is r here? Directly r value will be equal to x value. So actually r is the radial value, right? Radial value where square root of r x square plus y square. Here there is no y since it is resting on horizontal line. Okay, there is no y. Therefore r equal to square root of x square. Here x equal to how much? 40. R equal to square root of 40 square. Then your answer will be x equal to 40. Okay, now the next thing is how to calculate sigma r a square. Here since we have 6 number of boards, we can calculate both x square plus y square for all the boards. Okay, if you go for 4 numbers here, 1 2 3 4 boards, that is 4 extreme boards, your x value will be how much? X value will be 40 mm and y value will be 30 mm, and for these boards, for other two boards, your x value will be 40 mm, y value will be 0. Okay, if you calculate that, you will going to get the answers like this: 10,000 and also 3,200 if you consider all the 6 boards. Okay, so if substitute to the formula here, finally you will going to get the value as f2 as 200 by 11 kilonewton. So f1 is 10, f2 is 200 by 11. So since theta is 0, so that component will become 1. Okay, if you go for that component will become 0, cos component. Okay, resultant force equal to square root of f1 square plus f2 square, nothing but resultant force equal to f1 plus f2, nothing but 10 by 10 plus 200 by 11 equal to 300 by 11. 28.2 is the correct answer. So but while typing here, we need to round it up for the assume that your answer is 28.2.1.2. While putting here, you should type answer as for the one decimal place 28.2 kilonewton. So this is what different pattern where instead of asking at the extreme boards the maximum load carried by the board, here they asked it on the inner boards, that is a resting on exactly at the center. So they asked it here. So the calculations are easy when compared to the previous 4 problems. This one more type of problem on bracket connections of bolted connections. Okay, so one more problem they asked on the bolted connection. Here instead of force, if you observe here, instead of force they given moment. Now I will read the problem. A moment m of magnitude 50 kilonewton meter is transmitted to the column flange through the bracket using 4 20 mm diameter rivets, nothing but bolts, as shown in figure. So here they applied a clockwise moment of magnitude 50 kilonewton meter. Okay, this is what your bracket placed. This is the distance of between the two bolts. This was the distance between the two bolts. That is, if you take this one as a center, from this center, all the bolts are equally placed. Now what they want here, the shear force or the force induced in the rivet A. Where is rivet A? rivet A is the extreme bolt. Okay. So how to calculate this? So since we know the moment, okay, so in the previous problem if you observe, so the moment here is P into E is the moment that is connected to F2. Okay, if you take this problem also, directly you calculate F2. What is F2? M R by sigma R square. We know what is R, what is M. M is nothing but force into distance. We know this. P into E. So in this case, what is P? We don't know. What is E? We don't know. That's why they directly given the moment. That's why they written moment here. What is R? For A, we know how to calculate R. So you draw a radial line, you go for Pythagoras theorem. Opposite square by adjacent square. What is opposite square? 50 square. Adjacent square 50 square. Therefore, your R value will be square root of 50 square plus 50 square, 50 root 2 millimeter. So now the shear force in rivet A will be mr by sigma ri square. We know this, but what I want on the shear force induced in the A bolt, that is Fs. So if you have substitute all these values, you're going to get Fs value as 176.8 kilo Newton. Okay. So this is what one more type of problem. Instead of giving the bracket load in terms of point load, they given in terms of moment. So then also we can calculate easily the force induced in the member. Okay. So assume that instead of moment in this case, okay, instead of moment, if you give the vertical force, then you should how to calculate that? Then you can calculate again F1. If the as per the shear force due to the load, you can go for like this. That is F1 equal to the total force acting on the member divided by number of bolts. Okay. Here since they are given moment here, I have chosen this concept. So now I will move on to the welded connection. This is also a very important concept in case of connections part. So regularly they will going to ask 2 marks questions on this one also. Since we all know that there are different types of welded connections, what are those different types? So we can go for fillet weld, we can go for groove weld, plug weld, slot weld, and spot weld. So maximum in the field will go for fillet weld, where here there is no groove is required. Where second one is the groove weld or the butt weld. Well, this is what the example for butt weld. We'll keep this is one plate, this is one more plate. We'll keep one adjacent to other. Later we'll go for welding. This welding we call it as groove weld, where we need to make a groove here. Okay, like this. So whereas the bottom one is the fillet weld, we'll keep one above other. So like the here I kept as a T shape. Okay. So then that weld we call it as fillet weld. So almost 95% of the weld will go by fillet weld and groove weld. So in fillet and groove, almost 95% again we will go by fillet weld only. So in some circumstances we will going to use plug weld. Okay, in some circumstances we will going to use slot weld and spot weld. Oh, this is what the different types of weld. So now the some specifications exactly similar to the bolted connection. If you go for the size of the weld, they assume that if you're connecting two plates, how we need to select the size of the weld according to the code. So in the code, it is given in table number 21. Okay, in table number 21, the minimum size of first run of the fillet weld. Again, it depends on thickness of the thicker part. Assume that if you're connecting two members like this, okay, two members. So out of these two, whichever is thicker plate, based on the thicker plate, how much size we going to use? So assume that if a thicker plate size is up to 10 millimeter, you can use the minimum size as 3 millimeter. Okay. Again, if the plate size between 20 to 32 or 10 to 20, you can go for 5. 20 to 32, you can go for 6 for first run of weld. This part or this table in the code book, it will going to give us the minimum size of the weld which we need to select for welding. Okay, this minimum size depends on the thickness of the thicker plate what we are connecting. Okay, so whereas in case of butt weld it depends on the effective thread thickness. In case of fillet weld, we'll go by this table. The minimum size should not be less than this. Okay, so if you observe this table, assume that in the exam they may ask. So the minimum size of the weld according to the code is the minimum size we should provide for any kind of member. We should provide minimum of first run of weld as 3 millimeter. You should remember that. So next, if you go for effective length of the weld, so in practical on paper, the weld length will be different. While providing at the site, we need to provide 2 times of extra. Whatever drawing we have calculated, plus 2 times we should provide extra size. So size means what? Just now we can know what is size. The size of the weld is the main in the size of the weld we're going to use for the connection of different material. So whereas while calculating the effective length of the weld, you should take length of the weld required to connect the member plus 2 times of the weld size. That we call it as effective size of the weld. Whereas in case of this is in case of fillet weld, if you go for butt weld, then it shall be taken as the length of the continuous full size of the weld, but not less than the 4 times of size of the weld. Okay, this is for butt weld. If you go for other specifications, so the throat thickness is the K value. It is given in table number 22. So this is also very very important concept. What do you mean by effective throat thickness? So if you observe here in this figure, okay, here we're going to put a fillet welding like this. So all full fillet welding will not be useful for taking the load. Only some portion, okay, some portion of this weld will going to take the load. That effective portion we call it as throat. So we should know what is the effective throat thickness according to the code. So here they given in table number 22 the values of K are the effective throat thickness. Uh, the different angles of between the fusion phases. For example, if you place two plates or the two members in an inclination of 60 to 90 degree, if you go for welding, then you can take it as K value as 0.7. If you place 91 to 100 degree, then you can take it as 65. 0.65. Similarly, for other angle of inclination, we can take the thread thickness value like this. Okay, if you go for this example, here I have placed it exactly 90 degree here. What is the the angle of angle between the two fusion places? This is plate one. This is one more plate. So here the angle between these two plates will be what? 90 degree. Whereas here 180 degree. Okay, so this is exclusively for fillet weld I am talking about. So if the angle is varies to 120, or if the angle is varies 30 degree, if the angle is varies only 30 degree, 30 degree or 130 degree, so for fillet weld we need to choose the K value according to the code. So what will given in the examination, they may ask for, assume that they will give like this: if the angle of inclination between the fusion faces is 105 degree, then what is the K value? So then you should remember this value. So for up to 90 degree, 70, 60 to 90, 91 to 165. Okay. So under 101 to 106.6. So you should remember this value. This is a very important table. Next, if you go for the maximum size of the the welding, here whenever two plates or two members are meeting 90 degree, the maximum size will be the plate thickness minus 1.5 mm. Assume that if plate thickness is 10 mm, you are connecting to the bottom plate, then how much maximum we can provide here? 8.5, that is 10 minus 1.5. Whereas how much minimum size of the weld we need to provide for 10 up to 10 mm? We need to provide 3 mm. What is the maximum I can provide? 10 minus 1.5, 8.5. In a similar way, if you come across angles like this, curved edge, then your maximum size will be thick 1 by 4th of the thickness. So that gap we need to give. The maximum size will be 3 by 4th of the thickness. T minus 1 by 4t, you're going to get 3 by 4 times of t. Okay, this is what the S max value. What is S minimum value? S minimum we should take according to table number 21. S maximum depends on the edge we're meeting for, which are meeting at for the welding process. If they are meet at 90 degree, okay, sharp edge, then your value will be thickness of the plate minus 1.5. If the curved edge is meeting to the other plate, then you should take the maximum size as thickness minus 1 by 4 thickness, nothing but 3 by 4th of the thickness of the plate. That is what your maximum size. We are not supposed to provide like this. This is also wrong. This is also done. So this one you can provide, but this is when you are providing extra other than the material. The material thickness is this much, by providing extra. This also not acceptable. This also not acceptable. This one is acceptable, but we should go with the S maximum and S minimum concept. That is minimum size and maximum size concept. So if you go for some of the questions on welded connection, the maximum size of the fillet weld for a plate of square edge. Just previous case, if you observe, this is what the question they asked for 1 mark. So if the square edge, what will be the maximum size? So maximum size is option A here is 1.5 times less than the thickness of the plate. Second one half of the thickness of the plate. Thickness of the plate itself 1.5 times of the more. This not possible at all. Okay. So option A is correct answer for sharp edge. So thickness minus 1.5. Okay. If you go for one more question based on effective rod thickness, this was one of the previous year question paper question. For fillet weld of size S shown in adjoining figure, the effective thread thickness. Here you please check the angle of fusion faces. This is one plate, this one more plate, the angle of fusion face is 90 degree. Therefore, your answer here is for 99, your answer is 0.65. That is B is the correct answer. Okay. If you go to this table, so for 99 degree, what is the answer? 0.65 is the correct answer. That's why you should remember the thread thickness table. That is table number 22 of IS 800. So if you go for strength of the belt, so in case of a bolted connection, we calculated strength of the bolt for shear and also bearing. In the similar way here, in the class of code, they given for fillet welds, they given like this. So weld strength equal to FWD equal to design weld strength equal to FWN by gamma M2. We know this gamma M2 depends on site weld or field weld. That is partial safety factor for material. For site weld, the value will be 1.5 since we having less degree of quality control, and also for if factory or the shop weld, we can take it as 1.25. Whereas your the FWN will be FU by root 3, smaller of the ultimate stress in the material or the parent metal partial safety factor. This is what for fillet weld, design strength of the fillet weld. Okay, when subjected to combination of even the, this is only for shear forces. When it is subjected to what, the combination of normal shear forces, then we should calculate equivalent stress using this formula. F equivalent equal to square root of Fa square plus 3 q square, which is less than or equal to Fu by root 3 gamma mw. Okay, where Q is the shear stress, Fa is the normal stress. Which these formulas are very important to solve the problem. Okay, when the forces in the welding is acted upon by normal and shear stresses, then we should calculate equivalent stress using this formula. When the weld is acted upon by only the shear stress, then we should go by this formula, design strength of the fillet weld. So this is the last year question paper problem. Here, if you want to read the question, it will take 2 minutes. So here they directly given the figure. So what they want, I will go directly with this. What they want here is the weld length required to transmit load equal to full strength of the member R. Nothing but here you want L1 value and also L2 value. So here they given the figure. What we want here is L1 and L2. So this is a single angle connection member where this is what the gusset plate. Okay, angle CAYY is YY value is also given. Why? Because in examination we won't provide the steel code book or the steel table. That's why CYY is also given. Okay, so here what they want here is what is L1, what is L2. So now I will check what is the force acting in the member. What is the member here? This is tension member, which is acted upon by a tension force. Okay, angle connected to the gusset plate. What is the force acting in the member? So the force acting in the member is not given in this problem. If you read this, the weld is used for joining angle section ISA 100 into 100 into 10, gusset plate 15 mm, transmit tensile load, the permissible stress. Oh, this is like a working stress method problem. No need to worry. In place of stresses, we can put directly this value instead of using partial safety factor. Permissible shear stress in the weld is given. Okay. The location of the center COV is also given. The area of cross section of the angle is given. We require this one for the we may require this one for the calculations area. So L1 N2 rounded off nearest integer we should write. So and the effective thread thickness is directly given. You can take it as a 0.7 as a K value. Okay. Here what we required here is the how much load it is carrying. Here indirectly they given hint about the load acting in the member. So how much load it has to act? The load acting in the member will be equal to the full strength of the material. How to calculate full strength of the material? So what is load or what is stress? Stress is nothing but load by area. If you want load carrying capacity or strength, you need to multiply stress with the area. Since whether its area is given, yes, area of the member is given 1903 millimeter square. Whether stress is given in the member, yes, 150 mm is the stress in the permissible stress in the angle. So now what I will do, I will calculate the force acting in the member by using the formula load equal to stress into area. Okay, so what is load? That is question mark. We should calculate the full strength of the member. Stress is 150, area is 1093. Your answer is 285450 Newton. Okay. Next, what I want out of this 285 kilonewton, how much force is carried by top angle, that is outstanding leg of the angle, and connected leg of the angle. So later, if you know this, then I can calculate L1, L2, the weld required for to transmit these two loads safely. So now what I will do, I will calculate the P1. What is P1? Force induced in the outstanding leg here in this connection part. Okay, in this connection part, what is P1? P1 is nothing but force, is nothing but stress into area in the weld. What is the length? Area of the weld. Area of the weld is length of the weld into effective throat thickness. Length of the weld here is L1. They given in the figure. Throat thickness here is 0.7 into S, where S is the size of the weld. Whether size is given, if it is not given, automatically it is going to cancel. No need to worry. Then, uh, 1 second, whether the size is given, we will check. Permissible angle CY by 15 mm. 1 second, we'll check. Otherwise, it will going to transfer. Cancel automatically. No need to worry. So here they given. Sorry, here they given the size of the word 5 mm. So here you can put 5 mm. What is 108? 108 is the stress in the weld, permissible stress in the weld. So now we are calculating P1. P1 is the load. P1 is the load acting in the top weld. So that is stress into area. So area equal to length of the member into length of the member into effective throat thickness in the weld. That is area into stress. You will going to get 378 times of L1. If you calculate P2 similar to P1, L2 into throat thickness, effective throat thickness into stress. Again, you're going to get P2. Okay, 378 L1, 378 L2. If you apply about this CG, if you take moment P1 into CYY, okay, and P2 into this distance. P2 is what? The force acting in the L2. This is P2. Oh, this is P1. Okay. If you take moment of, since the joint in equilibrium, if you take moment about this centered line, okay, the P1 into CYY must be equal to P2 into the remaining distance out of 100. 100 minus CYY. Okay, CYY here is 28.4. So then you're going to get this ratio P1 by P2 equal to 731.6 divided by 28.4. Okay, where P1 is already calculated, L1 into 378. Okay, where L2 is into 378 is the P2. If you calculate this ratio will be 2.521, where L1 your L1 equal to in terms of L2 this value. So now if you equate the tensile strength of the weld equal to strength of the belt, since the joint is in equilibrium, whatever the external load acting on the member must be equal to the connection, the welded connection strength. So here the welded connection strength will be total length of the weld provided L1 plus L2, that is top weld and also bottom weld, plus the 3.5 is the length of the 3.5, and also the value here is 108 is a stress in the material. Okay, here 3.5 is what? 1 second, 3.5 is the length of the member. Okay, so if we equate this to the tensile strength, you're going to get L1 plus L2, and later you can calculate individually by equating these equations. You can calculate so L1, L2 separately. This is last year examination problem. You see here, this is a 2 marks question. To read the problem itself, you're going to take 3 to 4 minutes. So if you know the concept of this, writing the free body diagram also they are directly given. So here the concept we need to use here is the CG of the angle sections must be coincides with the CG of the welded connection. Okay, here indirectly we need to calculate the load carried by the member. They not given the load directly. We should calculate the full strength of the member. For that full strength of the member, we should design the weld. So this is what the problem they asked in the previous year for 2 marks. So in the next class, what we'll do, we'll discuss remaining problems on welded connections, and also I need to discuss importantly the plastic analysis in the session number 3. Thank you.